Hello and welcome back to Get Great at Maths. I'm here to help you pass your maths exam, so hit that like and subscribe button. We're going to look at keywords, key formulas and how to gain top marks. So let's get ready to get great at maths. In this lesson we're looking at solving trig equations, and we're going to be solving these trig equations between 0 and 720. And the three trig functions we're going to be looking at are sine, cos and tan, and we're going to be looking at solving sine x is equal to 0.5, cos x is equal to 0.5 and tan x is equal to 1. Now the key words in this question are the word solve and the values of x we're going between, so 0 and 720. So the key facts are that the word solve means find x. Now when we've done find x in the past, we've used trigonometry, and then you've come down to an equation where sine x or cos x or tan x equals a value, and then to find this missing value here you have to identify the correct trig function. In this case it is the sine one because we've got the opposite and the hypotenuse, and to find this missing value here x, we have to do sine to the minus 1 of the opposite divided by the hypotenuse, which will give you an angle, and this will give you your first angle, which will be an angle between minus 180 and 180 degrees. Now this angle that we get out here gives us one solution, but we want all the solutions between 0 and 720, so we need to work out how we're going to find more solutions. And to be able to do that, we're going to be looking at drawing the graphs for each of these functions and then seeing how we find multiple solutions to these equations. And you're actually going to find out for each of these equations we are looking for 4 answers for each of the equations. And we're going to see how to do that now. Now we're looking at solving sine x equals 0.5 between 0 and 720. Now to be able to do this, we're going to draw the graph of y equals sine x between 0 and 720. So this axis here, this is my sine graph. Remembering the special features of the sine curve, it starts at the point 0, 0. Then when it gets to 90, the maximum value is 1 on the sine curve. Then at 180 it comes back down to 0. 270 it comes back down to minus 1, and then up to 360 it takes you back to 0. From here the curve repeats, so exactly the same as what has happened between 0 and 360 then happens again. It goes back up to 1, down to 0, down to minus 1 and back up to 0. So between 0 and 360 and 360 and 720 the curve is exactly the same. Now this symmetry of the curve is really going to be important when we're looking at finding all the solutions between 0 and 720. Now the first step in order to find the value of x is we need to use your calculator and find sine to the minus 1 of 0.5 or inverse sine of 0.5. So on your calculator this is the shift button, then the sine button and 0.5, press equals and you will get an answer of 30 degrees on your calculator. Now what this means in relation to the graph, this 0.5 is key. This is the value on the y-axis. Okay, so this is this value here on the y-axis that you can see I'm clearly marking with the 0.5. So if we draw a line across at 0.5 until we hit the curve, and then draw a line down, you will see that we hit the mark 30. So this is my first angle. Now this first angle that we calculate here is going to be really important in working out the other solutions. Now as I said on the first slide earlier, we are looking for 4 solutions and we've just found one of them. So we've got to work out where the other 3 solutions are, linking our answer to this angle of 30 degrees. So to find the second angle, we're going to extend this line at 0.5 until we hit the curve again. So the first angle when we hit the curve was 30. This is my first solution. But where I hit the curve again, this is going to give me my next solution here. And we've got to work out what the value is. Now you can see from the graph it's going to be between 90 and 180. But we've got to work out exactly what this value here is. And to do that, we're going to look at the symmetry in the curve. Now this curve is symmetrical about the point 90. So here's the line of symmetry, it's just been drawn in as a blue line here, which means the distance from 0 to 30 on the left hand side is going to be exactly the same as this distance from the pink line to the 180. So this gap here is also going to be 30, which means to find our second angle, all we need to do is 180 take away 30, because the gap from here to here is 30, which will give me 150 for my second angle. We need to write that up next to our question. So I've got 180 take away 30 is equal to 150 is the second angle. Now, to find the third angle, we need to go back to the equation of the 0.5 and we need to extend the line further. Now, when I extend the line further, I now hit the curve at this point over here. When I draw a line down, this gives me the third solution here. Now, to work this out, we're going to be using the symmetry of the curve again. Now, you can see that the distance from 360 to the green line here is going to be exactly the same as the distance from 0 to the red line here, which was 30, which means our next angle is going to be 360 plus 30, which takes me to the next angle here because of the symmetry of the curve. So I've got 360 plus 30, which is 390, which gives me my next solution. Now you can see that the distance from this line here at 30 to the line where my third solution is has a gap of 360, and that's really important, but we remember that the curve repeats every 360 degrees. To find the fourth angle, we're going to extend the line further. When the line hits the curve again, we're going to draw a line down, and this is going to be my fourth angle. These are all the four solutions. So I've got 1, 2, 3, 4 solutions between 0 and 720. That is when the graph of y equals sine x is equal to 0.5. So we could just have drawn a line all the way across to start with, and we could have seen there were the 4 solutions up here. Now we're looking at the fourth solution now. Now using the symmetry of the curve again, okay, so we can see this curve is symmetrical here. The gap between 360 and the green line was 30. So the gap between 540 and the brown line or the yellowy line is also going to be 30. So we can also see that from the second angle we got of 150, if I add on 360 again because of the symmetry of the curve, it will give me the new angle as well. So there are a couple of different ways of thinking about this. Now the easiest way, so it follows the same method every time, is to take the second angle, add on 360, and that will take you to this angle here. Or you could have done the 540 take away the 30, which will also give you an angle of 510. It doesn't matter which way round you do it, but it is easier to think of one method that suits all, and the method that works for every single case is adding 360 to your second angle. So if we work out our first angle, we do 180 minus the angle to get the second angle. To get the third angle, we add on 360 to our first angle. To get our fourth angle, we take the second angle and add 360 onto it to give you the 510. So our key facts that you need to write down are the first angle, x, we need to use the inverse to find that value of x. To find the second angle on the sine curve, you need to do 180 take away the value of x. If you add 360 degrees to both the angle you got in the first one and the second angle, that will give you the third and the fourth angles. So if you add 360 to your first and your second angles, that will give you the third and the fourth angles, and that will give you the 4 solutions. So your first one here for 30 was for doing the inverse. The second angle on the sine curve is always 180 take away the angle that you've just worked out. The third angle is 360 plus your first angle, and the fourth angle is 360 plus your second angle. Make sure you've written down these key facts over here in red and highlighted them and stick them in a nice bubble. And make sure you've drawn down the graph so you understand where all the different solutions are coming from. This is how we solve all of them. So I've just shown you the sine curve to start with. We're now going to move on to the cosine and the tangent curve and do a very similar method. Now we're looking at solving cos x equals 0.5. And to solve cos x equals 0.5 between 0 and 720 means we need to know what the shape of the graph is going to look like between 0 and 720. Now the sine curve and the cosine curve are very similar, but the cosine curve starts at the point 0, 1. So the sine curve starts at the point 0, 0. The cosine curve starts at the point 0, 1. Then it comes down to the point 90, 0, goes down to 118, negative 1, 270, 0, and then up to 361. Now the curve then repeats between 360 and 720. It does exactly the same as what it did between 0 and 360. You'll be expected to know the shape of the sine curve, the cosine curve, and the tangent curve in your exam. So make sure you know what those graphs look like. Now from here, we're going to work out the first angle. So if cos x equals 0.5, you'll need your calculator for this bit. And to find the value of x, you need to do cos to the minus 1 of 0.5. You literally just need to type that in on your calculator. Remember to make sure there's a little d on the screen at the top to make sure you're in degrees. And the answer you should get would be 60. Now what this means in relation to the graph is we look at the value of 0.5 again. So from 0.5, I'm going to draw a line across, and then I'm going to draw a line down. So if I come across at 0.5 and then draw a line down, this gives me the angle of 60 degrees. Now from here, I've got my first angle. I now need to work out my second angle. So to find my second angle, I'm going to draw a line across from 0.5. My first angle is where I hit the curve first. The second angle is where I hit the curve second. I draw a line down, and you can see clearly from where it is on the diagram, it is coming down at 300. But we're going to look at the reason why it is coming down at 300 and how we'd work that out if we couldn't see exactly where it was coming down. So this time we're going to imagine that we've got a line at 0 and we've got a line at 360. Now the curve is symmetrical about 180. Okay, so it's going to be symmetrical about this middle point here. So between 0 and 60 is the same as the distance on the right hand side between 300 and 360. So this is the same gap. So to calculate this second angle on the cosine curve, we do 360 take away 60, which gives me the 300 degrees. You could see from the diagram it was going to come down at 300, but the reason why is because it is 360, this maximum point here, take away the first angle, which was 60, which gives me the 300 degrees. So my second angle is 300. I'm now going to look at working out my third angle. Now the third angle, I then go back to 0.5 and draw a line all the way across. When I get to this point here, I hit in the curve, I draw a line down. Again, I'm going to look at the symmetry of the curve. So between 0 and 60 was the gap here. So from this center line here at 0 was a gap of 60. It's exactly the same again here. This blue line here is like the point at 0. So the gap from here to the green line is also going to be 60. So to find my third angle, I've got to do 360 plus 60, which is 420. You can see that gives me my third angle, and the gap between 60 and my third angle is going to be 360 because of the repetition of this curve. So to find my third angle, I just need to add 360 to my first angle to get the third angle. For the fourth angle, I'm going to extend the line further until I hit the curve again. So you can see there is 1, 2, 3, 4 solutions. Okay, so we've looked at the first 3. Now we're going to look at the fourth solution. Now from here, we can see I can draw another line down here, which means that the gap here at the end is going to be 60 again. So the symmetry of the curve is really, really important. We also know that we were at the point 300 and the curve repeats every 360. So if I add 360 plus this 300, that will also give me my fourth angle. There are a couple of ways of doing it. Now if we do 360 plus 300, that will give you 660. It's also the same as 720. Take away the 60 that we had. That will also give you your fourth angle of 660. Now the key facts which will always work for every single question are that to find your first angle, x, you need to find the inverse. To find the second angle on the cos curve, it is always 360 minus that first angle. Okay, that is a rule that is always important and always works to find the second angle on the cos curve. And you can see because of the shape of the graph, this distance here will always be the same as the initial distance here on the left. To find the third and fourth angles, you need to add 360 to your first angle and your second angle, and that will give you the third angle and the fourth angle. Please write down the key facts, make sure you've highlighted them, stick them in a bubble, and make sure you know how to find the second angle and third and fourth angle on the cos curve. So that gives me all the solutions between 0 and 720. As I said, for each of these questions, we are looking for 4 solutions to between 0 and 720 because of the way the graphs repeat. The next function is the tan function. So we're going to look at the graph of y equals tan x, and we're going to solve from tan x equals 1 between 0 and 720. Now the tan curve looks totally different to the sine curve and the cosine curve, and you'll be expected to know what the tan curve looks like in your exam. So the tan curve is like the sine curve, and it starts at 0, 0, but it forms these little sections here where it goes between 90 and 270. It never reaches 90, so you get an asymptote appearing at 90. You will also get an asymptote appearing at 270. That just means the curve will never hit the graph at this point. The next asymptote will be at 450, so the graph will never reach at this point. And you will also get an asymptote further along here as well at 630. This is where your asymptotes are going to occur. The shape of the graph is always the same. This curve always repeats every 180 degrees. And we're going to be using that fact later on to see how we work out the missing angles. Now, in this case here, we're looking at when tan x equals 1. So to find x, on your calculator, you will need to do tan to the minus 1. Make sure your calculator is in degrees. If you type that in on your calculator, you should find you get an angle of 45 degrees. What that means in relation to the graph is if you come across at the point 1, draw a line down, this angle here that we've just worked out is 45 degrees. To find the second angle, we need to extend this line across here, so this gives me my second angle. Draw a line down, this will take me to my second angle. Now I can draw a line in at 180, which is like the y-axis. So the gap between 0 and 45 is 45 degrees. That means the gap between 180 and this pink line is also going to be 45 degrees. So to find my second angle on the tan curve, it is 180 plus the first angle, in this case 45, which is going to give me 225 degrees. So my second angle is 225 degrees. The third angle comes from extending the line further. Get to this point here where it crosses the curve and draw a line down. This will give me my third angle. Now you can see here the curve is very symmetrical. Okay, you could draw a line again at 360. Say this gap is 45 again. So draw the line at 360. The gap between is 45. So the gap from here, from 360 all the way up to here, is a gap of 360 because the curve repeats every 360 like the sine curve does and the cosine curve. More specifically on the tan curve, it does repeat every 180 degrees. So if you'd have taken this 225 and added 180 to it, will also give you the next angle. So the next angle here is going to be 360 plus 45, which is going to be 405. By sticking with adding 360, it's the same method for the sine graph and the cosine graph. The fourth angle comes, okay, from drawing the line across at 1. So I've got one angle, second angle, third angle, the fourth angle is where we hit the curve again. Draw a line down. You can see again at 540 is where we're symmetrical about, and we're going to add on that 45 to the 540 to get the next angle. Or we can think about our second angle, which was 225. It repeats every 360. So if I do 360 plus 225, which gives me 585 degrees, my fourth angle is 585 degrees. The key facts to be able to solve this question for any single problem are: to find the first angle, x, you need to use the inverse. To find the second angle on the tan curve, it is 180 plus the first angle. And then To make the rule the same for all of the functions, if you add 360 to the first and the second angles that you just worked out, that will give you the third and the fourth angles. There are alternative methods to use the tan one, but if we stick with this method, it works exactly the same for all three trig functions. In summary, we're going to link all the key facts that you need to know for the sine, cos and tan graph so you can solve for any single scenario. So remember, we're going to be solving between 0 and 720. Our key facts, the word solve means find x, and there are going to be 4 solutions between 0 and 720. The inverse of a trig function finds the first angle, which will be an angle between minus 180 degrees and 180 degrees. To find the second angles, this depends on which curve you're looking at. So if you're looking at the sine curve, it is 180, take away the first angle, which was x. For the cosine curve, it's 360 minus the first angle, or 360 minus x. For the tangent curve, it is 180 plus the angle x, or your first angle. So you need to remember these 3 things to find the sine, the cosine of a tangent, or you can remember what the graphs look like and you can use the symmetry of the curve to work out the second angle. The choice is yours. Then, to find the third and the fourth angles, you will need to add 360 to your first and your second angles, and that will give you your third and your fourth angles. As long as you remember all these facts or remember what the curves look like, you will be able to solve any trig function between 0 and 720. Now, normally in the exam, they only ask you to work out the solutions between 0 and 360. And between 0 and 360, there are only going to be 2 solutions. So you won't need to do as many steps as we've looked at here. But if you're going on to do A-level maths, you will need to know how to work out the third and fourth angles because they will be really useful later on. So please make sure you know how to repeat the curve and how to use these functions. If you've enjoyed this video, please don't forget to like and subscribe. Comment below to let me know what you would like to see in my next video. See you next time!